All right, so today we're going to finish up our discussion about activity-based costing. We said that there's other methods of applying manufacturing overhead, some other conventional methods, but we said there's some shortcomings with what? Plant-wide overhead rates, departmental methods for allocating costs. What was the shortcoming with those methods for allocating overhead? What was the biggest challenge? Well, we said certainly it's a method of accounting that's been used for a long time, but activity-based costing, we believe, is an improvement over those methods of applying manufacturing overhead. Why? Because we said those methods of allocating manufacturing overhead are based on volume. So it focuses on the number of direct labor hours or the number of machine hours. And we said that companies, very often they produce more than one product. Some production processes are very highly automated. So looking at direct labor hours is going to result in a misallocation of manufacturing overhead. So we don't want to just focus on volume metrics. And activity-based costing, we're going to go through an example now. Activity-based costing focuses on the activities that cause the cost to be incurred. So does that make sense? So instead of just looking at how many hours, and at one time manufacturing processes were very labor intensive, and to some extent it made sense to look at direct labor hours to assign overhead costs. I mean, certainly you want to know what the direct labor hours are. We want to know what our direct labor costs are. Because remember when we put together the schedule of cost of goods manufactured, we spent a lot of time looking at what the direct labor cost is. So it's not that we don't want to look at direct labor costs. We need to know how many hours we're putting into direct labor. We want to know the number of machine hours. But the question is that the best way to allocate manufacturing overhead? And manufacturing overhead, we said, is the indirect labor and indirect materials. Questions? So does that make sense? What do you think? Who could paraphrase what I just explained? What do you think? We said that we have these manufacturing overhead costs, which are the direct labor, the indirect labor and the indirect materials. So we need to allocate those. But we said that, what's the problem? What's the problem in allocating those manufacturing overhead costs? Because remember, at first we spent a lot of time figuring out what the manufacturing overhead was. Now that we know, our challenge is, well, we said that we make multiple products in our facility.
You have to assign direct labor to a product. You can't do that when you're using manufacturing overhead because of the overall calculation.
Good. So there's a difference between costs that are direct and those costs that are indirect. So manufacturing overhead costs are indirect costs. They're not costs that are easily traceable to a particular product. So we group them together and we classify them as manufacturing overhead. There's other costs, like the direct labor, direct materials, that we're able to trace to a particular product. But then, once we group all these indirect costs together, and we know that we have a certain amount of manufacturing overhead, these indirect costs, then we need to allocate them. Isn't that right? What do you think, Dallas? Is that right? Or no? No, think it through. We have these manufacturing overhead costs. Remember when we did the schedule of cost of goods manufactured? Right? Try saying that 3 times fast. That was pretty good, right? What's going to happen? We've identified the direct labor, the direct materials, and the manufacturing overhead. And that's very helpful to us. But in our manufacturing facility, we make multiple products. So we need to allocate the manufacturing overhead costs. Because we really don't know, is it from product A that we made in the facility? So is it from the CD player that we make in the facility? Is it from the DVD player that we make in our facility? Is it from that flat panel, high definition, 1080 Pi, 55-inch LCD monitor? Now that you have to rehearse before class if you want to be able to say that. So we make all these electronics. And we said Mary is our plant manager. So Mary's the plant manager. We make all these electronics. But we have some costs that we could allocate to the monitors, some costs that we could easily trace back and allocate to the monitors, to the CD players, to the DVD players, to the computers. But then there's other costs that we can't. So our challenge at this point is, having identified the manufacturing overhead costs, how do we allocate them? How much do we allocate to DVD players? How much of Mary's salary? Because we pay Mary $150,000 a year. You think we should pay her more? What do you think? No, that's enough? Okay, so 150, Mary, that's it. You're capped at 150,000. So Mary gets paid $150,000 a year, but we make all these different products. So the question is, what percentage of Mary's salary are we going to allocate to the DVD players? What percentage to the computers? What percentage to the CD players? That's what we need to determine. So previously, what accountants did was they looked at for a particular product in a facility, what percentage of the total labor hours was used to produce the DVD players, and what percentage of the total hours were used to make the computers. And then, so what we did was we took that percentage and we said that percentage of Mary's salary will go to computers, and this percentage will go to DVD players, etc. But we said that many manufacturing processes have become automated. So direct labor hours is not as relevant in allocating costs. Now again, we still need to know what the direct labor hours are. We still need to know what those costs are. But it's not a relevant tool for us to assign costs, to assign manufacturing overhead to a particular product. So we use activity-based costing. So let's look at some examples. All right, here's an example of an activity. All right, it's from problem 311. What page? She's on page 133 and you're on page 155. How can that be? Right. Okay, so far we got 2 out of 3, so it's 155. I don't know. I hope it's the same book. All right, so the first question says, Now this is an example of an activity. So this is an activity that we could use to allocate manufacturing overhead. All right, so the first activity is machines are set up between batches of different products. All right, batch, and then how are we gonna measure that?
Time.
Yeah, Tatiana?
Time.
Time, and what else? Right, Javon says the number of setups. All right, good. So the setup time and the number of setups. The second one says the company's ground crew maintains planted areas surrounding the factory. So what that means is they have grass and bushes and flowers that grow around the manufacturing facility. So when customers come, very often when customers are going to make a deal with a company, they want to visit the manufacturing facility. They want to see what do the operations look like. Right, so level would be facility, and then yeah, it could be the number of employees, or right, could be the number of hours as well. Questions on that so far?
Could it be maintenance hours? Because in many companies it's considered as maintenance.
Yeah, it could be maintenance hours.
Can you call it what you want? Yeah, that's what I was
thinking.
thinking.
Well, yes, you could, but the thing is that it's got to be a relevant metric. So if it could be even like the number of flowers that you planted. If that's all that the crew did, this maintenance crew that Melissa's talking about, if that's all they did is plant flowers, then okay, then that's fine. Then that's very relevant. If they're doing other activities, then we need to find a more relevant metric. Yeah, but as long as we're consistent and it's logical, remember, this is what we're going to use. Why are we talking about this? Because what we want to do is figure out, now that we have $350,000 that we spend each year to plant flowers and mulch around the manufacturing facility, how do we allocate those costs? That's what we need to try and figure out. All right, so questions about that? No? Okay, good. All right, Olga, help us with the next one. You ready? No pressure. All right, here we go. Milling machines are used to make components for products. So we have a product, there's a variety of different components. We have a machine that makes the different components for that product. So what level are we looking at? Unit, right?
And it's dollars per machine hours.
The number of machine hours, and what else? Whoa.
Units.
Elena, go ahead.
Number of units.
Right, the number of units that the number of units of the components that are made.
Okay.
Can I skip C?
Yeah.
Okay, we'll go back to that. But do you see why that makes sense? When we talk about the machine, the milling machine that's used to make component parts, why the number of units processed makes sense? Why is that?
But machine hours also correct.
Right, absolutely, you could use machine hours. But why? How does that relate back to how we're going to allocate the course? And true, but the thing is that that machine is going to make component parts for 5 different products. So if that's the case, what we need to do is we have to allocate that cost. So we need to know, how are we going to allocate? Well, Olga said machine hours. Elena said the number of units produced. So that makes sense. Maybe some products may not even use the milling machine to make component parts. So then we shouldn't allocate any of those costs to that product. That's what we're trying to determine, is how much of the cost should be allocated to each product. Because we need to know what are the product costs. Remember the first day I said to you, I said, it seems kind of simple to think, well, how do we determine the product cost? think, oh, that seems pretty straightforward. We should be able to know that. But it's not, as we've seen over the last few weeks, it's not as simple as it might seem. So that's what we're trying to figure out. Okay, so Carolina, we're going to talk about C now. A percentage of all completed goods are inspected on a random basis. It could be product, but what do you think is a better choice? Better than that. Unit level. Unit level is the better choice. A percentage of all completed goods are inspected on a random basis. That means we're going to look at it at a unit by unit basis and determine which ones are defective and which ones are not defective.
So wouldn't that be considered like testing out the product though?
Right, that's what we're doing. We're doing a quality control to determine which products are safe to sell.
So then it could be product too, right? Yeah, so it is product level.
Yeah, it could be product. Yeah, you could argue product. I think unit is really a better choice, but it could be. You could argue it could be product.
You're always trying to find the most specific, or this product is like general, you know, right? On a
Right.
general level, but unit is more specific, so.
And what would be the
Okay, so what would be the activity measure? How are we going to measure that? So I heard Siobhan, I think you said inspection hours? No, you didn't? Oh, okay. But that would be right, though. Inspection hours, and then what would be another option? Right, number of units inspected. So maybe you're going to inspect 1,000 units. Maybe you're going to inspect 500 units. Remember, when you go into a factory and you're doing an inspection, don't inspect the ones that Mary tells you to inspect. Right? You need to do a truly random inspection. So if they tell you check the boxes on top, check the boxes on the bottom. Because, of course, the ones on top are not going to have any quality issues. Because that's the ones that they're telling us to check. But ideally, we should know when the process goes out of control before the production quantity has been produced. So we should know beforehand. You don't want to wait until you produced 150,000 units and then find out, oh, wait a minute. Yep, I listened to Professor Bassell. I didn't check the ones that Mary told me, but now I'm checking these boxes and 10% of this box has defects and 20% of this box has defects and 40% of this box has defects. Then what? Then what do we do? We've got 150,000 units and between 20 and 40% of them are defective. We've got a problem. So you want to wait, you want to detect the issues early on in the process. And plant managers and factories in general have been empowering people on the floor in the manufacturing facilities to stop the process when there's issues, when they know that the process has gone out of control. Because any process is going to have an upper control limit and a lower control limit. So you don't want to just keep running. What was the concern before about the process continuing to run on an ongoing basis? Why would we want to not stop the process? What do we call that when we stop the process?
It's not making money.
It does. It's gonna have an impact on our profitability. It's referred to as downtime. And Greg is right. When there is downtime, that means that the costs, the fixed costs, are going to be spread across fewer units. Because if the manufacturing equipment is not running, then we're not making product. So in manufacturing, the way that you could maximize your profits is by making the greatest number of units possible so that you could spread the fixed cost over more units. And what happens? Our total fixed costs, do they stay the same or they change? What do you think? I hear different answers here. We should all have the same answer. What's going to happen to our total fixed cost? Right, Elena says that our total fixed costs stay the same. Our total fixed cost. Remember I said that sometimes students on the exam, they write that fixed costs are costs that are fixed. So fixed costs are going to stay the same. But what happens is the amount that each unit is going to absorb is going to well, you had a 50-50 chance. Well, so I hear some of you saying increase, some of you saying decrease. What do you think? Robin, tell us what you think. And no, well. Okay. Let's ask our plant manager. This is our total fixed cost. Our total fixed costs are going to stay the same over time. But what's going to happen is the unit cost, each unit is going to absorb less. So the amount that's going to be absorbed in each unit is going to decrease. That's different from variable costs. Our variable costs are going to increase with the production quantity. Remember we said that the fixed costs are not impacted by the production quantity.
Wait, you lost me.
Yeah, you lost me.
Okay. So let's go over it again. This is our fixed cost. Our fixed costs do not vary with the production quantity. Does that sound familiar?
Yes.
Our total fixed cost, actually, we should say our total fixed cost. So whether we produce 1 unit or 1 million units, right, Crystal? Our fixed costs are going to be, let's say, $10 billion. However, what happens to our total variable cost? If we produce 1 unit, 2 units, 3 units, 1 million units, our variable costs, our total variable costs are going to increase. Why? Because remember the first day you gave us that wonderful example about plastic, right? And that's going to be the example we're going to use the whole semester. You're going to become famous. You're already famous.
Trademark.
So, if we're making 1 unit, we're using 1 ounce of plastic. If we're making 2 units, we're using 2 ounces of plastic. 3 units, 3 ounces of plastic. So our total variable costs are increasing. But what do we say about the variable cost per unit? The variable cost per unit, it's the same. Isn't it the same? The variable cost per unit is the same unless, remember we talked about relevant range. So between 1 unit and 10 million units, we're going to say that's our relevant range, and at anywhere in between that range, we're buying plastic at 52 cents an ounce. But then, if we're producing more than 10 million units, we might be able to get a volume discount. That's why we talk about the relevant range. You follow?
I'm following, but I want to know why. And the fixed cost will actually decrease if you have downtime.
Okay, so what's going to happen is, if it's $10 billion for our total fixed cost, if we could produce, let's say, 10 billion units, let's say 10 billion units, if we run the factory 24 hours a day, 7 days a week, so that's our production capacity, is 10 billion units, then each unit is going to absorb $1. But then what happens if we have to shut the machine down? That means now we can't produce $10 billion, 10 billion units anymore. Let's say we have to shut the factory down the entire day because we have to order a part for the machines. That means that now, let's say we could only, let's just say for example, make 9 billion units. So what's going to happen? Come on, you guys are accountants. 10 billion divided by 9 billion is what?
$1.9. $1.10.
Good.
Why not?
That's amazing. I'm impressed.
I'm not.
You're not impressed? You should. You should. That's good.
So what happens?
So now the amount that each unit is going to absorb is $1.10 instead of $1.
So then it increases.
So increases.
Right.
But you said it decreases.
Did I say that?
That's what you said.
No. I was answering a different question.
How many units we can produce? That's
Right. So
that's not what
That's not what you said. though. You said it.
wait, there's two different questions on the floor here. Okay? Two different questions on the floor. One of them is what happens to fixed costs, right, when you produce more units? Right? In this case, we're saying we're producing less units. Right? So the reason why we want to produce more units is because the more units that we produce, the smaller the amount each unit is going to absorb. Right? So that's this situation. So there's different scenarios. One is we produce 10 billion units. Another is we produce 11 billion units. And another is we produce 9 billion units. So when we produce 11 billion units, then the amount that each unit is going to absorb is going to be less. If we produce only 9 billion units, then the amount that each unit is going to absorb is going to increase. So that's why we want to maximize our production. That's why we want to make as many units as possible so that we could spread this fixed cost. And this is the reason why, for example, in the US, we said that car manufacturers are struggling. Why they have so much trouble being profitable? Because their fixed cost is very substantial, because their manufacturing capacity was built in the 70s when they were the market share leader. When they were producing hundreds of millions of cars. But then what happened? Toyota, the car that moves forward on its own, right? Whether you want to or not. But that's their slogan, moving forward. Details, right? Details, moving forward. So they're stuck with this huge fixed cost. And that's what they're trying to manage. That's why they're trying to consolidate their operations so that instead of in one factory, they're making 4 billion units, they're making 9 billion. So that the number of units produced are increasing. And when that happens, the amount that each unit is going to absorb is going to be less. Are we good? Are we great? Yes. Fantastico. All right. Let's keep rolling. All right.
C.
C. E. Employees are trained in general procedures. All right, Caroline says facility, because we're going to do the training for the entire manufacturing facility. Everybody's going to be trained. So facility would be appropriate. And then what is going to be our measure? What was that? Elena, go ahead.
It can be the number of employees trained or number of hours of training.
Right. Does that make sense to the rest of you? She said either the number of employees that we train, so either it's 400 employees or 4,000 employees, or the number of hours? No? Change your mind? Gotta get back?
Where are these names coming from? Like, you just, so I don't know how to very close.
But this is what we're, these are the, this is what we're using.
That those, I mean, the activity measures, where is it coming from? Like, you get them from the questions or?
There's examples in the book. Most of the time it has to do with the number of hours, the number of employees, the number of products, the number of purchase orders, etc., the inspection time, the number of inspections, and so on. So we know what the total cost is, but we don't know what we don't know is how to allocate it accordingly. All right, so training, we did that, E. All right, F. Purchase orders are issued for materials required in production. Batch. And? Right, number of purchase orders. All right, the next one, G. The maintenance crew does routine periodic maintenance on general purpose equipment. What level is that? Who said facility? Now you're fessing up? Right, Siobhan is right. Facility. Why is it facility? It's for the entire facility, the maintenance crew. So they're doing routine periodic maintenance on general purpose equipment for the entire facility. What does that mean, general purpose equipment? It's not just for one specific product. It's for the entire manufacturing facility. They say general purpose equipment. It could be vacuum cleaners. Is that an example of general purpose equipment?
Yes.
Or what they use to shine the floors. All right, and so what's going to be the activity measure? Number of hours, or
Number of employees.
the number of employees in the maintenance crew? Maybe. How would
Many
that?
places do have them divided, as in facilities, maintenance, engineering, production, operations.
And so then how would we use the number of employees you're saying for the maintenance
On
crew
the maintenance
to
arm.
allocate them, to allocate it?
How do we want?
How do we allocate, based on the number of employees, how are we going to allocate that course?
For the whole place?
Right. Well, in this case, we said it's a facility, so
Their salaries.
that would be interesting. Or the number of hours that they work.
I have number of hours or number of employees. It depends on how big it is, it depends on how many people you need.
So the more people in this crew, the more hours that they're going to work.
No, the less.
Good, 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 good. Yes, yes, that's good. Good answer. All right. The plant controller prepares periodic accounting reports. So this controller works in Mary's office. So this is a facility level, and then how are we going to allocate the course of the plant controller? Number of reports, what else? Number of hours. Could be if all that the controller does is prepare reports, and that could be meaningful. But there could be other responsibilities. So probably in this case, the number of hours that the controller is working.
But don't they have set salaries?
Oh, so what did you put?
I think hours, because we need to pay them. It depends
Right.
on hours.
Yeah, so but what I'm saying is that if all they do is reports, then that would be meaningful.
Isn't the controller's salary fixed?
Sometimes maybe yes, sometimes not.
Most of the time it is.
Yeah, that would be Yeah, it would be a fixed wage, salary.
They hiring for a few hours a week.
What was that?
If they hiring for
Then it wouldn't be a controller, it would just be a,
Intern.
not even, consultant.
So what do you think is the best way to allocate it then?
Then administrative expenses?
But let me ask you this, even though the salary is fixed, so the controller is an accountant, let's say that the controller makes as much money as Mary. Graduated from Brooklyn College, passed the CPA, makes $150,000 a year. So even though the salary is not going to vary by the number of hours, in terms of what we're trying to do, in terms of allocating costs, would the number of hours still be relevant? So what do you think about how you would allocate? So given that it's fixed, so it's $150,000, and then our challenge is, then how do you allocate that salary? What do you think?
You make the controller to count his hours. Like this day I work 5 hours on the reports and I work 5 hours on the balance sheet. So and they record their time. That's how you allocate it.
What do you think?
For overtime and double time, you can't have a fixed salary if you're working for an employee.
Right, so we're not saying that the controller is going to get overtime, but so the more hours that they work, the smaller their hourly wage would have been. But if we look at the number of hours that they work in a given year, that would help us to allocate that expense, that manufacturing overhead. If we look at the total number of hours. Now we, at the beginning of the year, we might make some assumptions about how many hours the controller is going to work. And then at the end of the year, we'll have to make an adjustment if we go with that measure. So we might assume the controller is going to work 40 hours a week. But then if at the end of the year we find out, well, actually, no, the controller worked an average of 48 hours per week, then we could allocate the course differently. Right? We could make an adjusting entry. In some cases, we're going to be over-applied. In some cases, we're going to be under-applied. What's the next one? Okay, I. Material is received on the receiving dock and moved to the production area. Yeah, it could be either batch or unit. Both of those are good. And then, Greg, let me get
Number of moves.
Yeah, the number of moves. That would certainly be good. Anybody have anything else? How much materials? Like what? So it could be the number of units, or you could say maybe the number of boxes, or the number of pounds. All right, the next one is J. The engineering department makes modifications in the designs of products. Right. Good. Wow, I think everybody agreed on that one. All right, and then the activity measure? Right, the design time, or the design, the engineering time or hours. All right, the next one. The human resource department screens and hires new employees. Right, facility. They're hiring people for the entire organization. And that's a very challenging responsibility, because keep in mind, let's say that we decide that we're going to operate 3 shifts instead of 2. So instead of operating from 12 to 8 and then from 8 to 4, we decide we're going to operate another shift from 4 to midnight. Now that sounds like a good solution if we expect to get a very big order from a new customer. So you say, okay, good. We don't have to open up a new manufacturing facility. We don't have to buy any new equipment. We'll just open the factory more hours. But then wait a minute. Who are you going to have work there? you might need to hire 250 more laborers to operate the equipment. So that's going to have a significant impact on the human resource department. So we're going to have to rely on them to recruit and select people to work in the factory. And that takes time. So the reason I mention that is that that's not like a quick fix, per se. Now at first we might do what you were alluding to is we might have people work overtime. And in some cases that could be feasible, depending on the type of equipment that's being used. So why do I say that? Why would that matter? Because if it's a very significant piece of industrial equipment, you don't want people falling asleep at the wheel, so to speak. If they're responsible for operating the equipment, and we say, oh, just do a double shift. Do a double shift. If this guy falls asleep, the whole factory could blow up. So you might say, okay, work 2 extra hours to help us get by. But ultimately, that's probably in the long run not going to be the solution. We're going to need to hire people. And so I think this is a good example of where we're going to have to hire more people and utilize the human resource department. And that's going to be an example of manufacturing overhead at the facility level. And then what are some of the possible activity measures? What do you think?
Number of employees.
Number of new employees.
Right, the number of new employees is good. Anybody have anything else?
Training.
Yeah, the number of hours. And the last one is production orders are issued for jobs. Batch. And the measure is going to be... What was that? Elena, go ahead.
I think number of orders.
Right, the number of orders. Anybody have anything else? Yeah, the number of orders is a good measure. All right, questions? All right, let's keep rolling. We can do it, yes we can. All right, we're going to look at this example, which is 3.7. What page is that, Irina?
153. It's the same.
Oh, Miss Clementos. Okay, good. All
I
right.
know you speak Russian.
Yes, everything is commercial. All right. That's a Sylvan company. All right, so Sylvan Company is a company that makes 4 different products. And what we're trying to figure out is how do we assign the overhead to the products. All right, so they give us some of the information. What do they give us? They give us the actual activity. So we did 3.6 in class last week. And so we calculated some of this information already. Right, so we calculated the labor rate is $7. All right, $7 per direct labor hour. And the actual activity in this case, now they tell us, is what?
8,000.
Which gives us
56,000.
56,000. All right, what is the activity rate that we calculated for the purchase orders? $60 per purchase order. And for product A, how many orders?
100.
Which gives us $6,000. All right. What's the activity rate for parts management?
$300.
$300 per part. 20. How many? 20 parts, right? Which gives us, okay, that's the applied overhead. And then for board etching, 180 per board. This case, for this product, it's 0. We'll see for product B, it's 1,500. And what about for a general factory?
555.
How many machine hours? Which gives us?
8,000.
Which is how much?
148.
All right, 148,000. Everybody got that? All right, this is just for product A. So now what we're going to do is we're going to look at product B. All right, so the activity rate that we're using is still the same. Remember, we calculated the activity rate already. This is 7. This is 60. 300. 180. And $5. Okay, so what for product B now, we're doing the same calculation, now we're going to do it for product B. What is the actual activity for labor? 12,000 direct labor hours, which gives us 84,000. The number of purchase orders? 300. This is 18,000. What about parts? 90 part types, which means that our applied overhead is 27,000. And our board etching now, here was 0 for product A, right? 1,500, which gives us how much for applied overhead? 270,000. And general factory, how many machine hours? 24,000 machine hours. 120,000. Right, 519. Everybody got that?
Yeah.
Everybody know why we're doing this? So as a first example, last time we looked at just one product. Now what we want to do is see, well, what about if we're making more than one product? In this case, we're making 4 different products. What is the manufacturing overhead going to be? So for product A, it's 148,000. For product B, it's 519,000. And for product C is
762.
What?
348.
No, 456.
all right. How many got?
52,000.
How many got 456,000? All right, 456,000 is the right answer. How many got 762,000? Okay, so 456,000 for product C, and for product D, what did we get? 165,000, which gives us the total amount of overhead applied is, yes, I hear you there. Right, 1,288,000. All right. Good job. All right, let's go back and talk about process costing. Remember we said job order costing is where you're going to make what? Unique items. So each job you have to cost out separately. Each job is unique. If we're painters, remember we said, well, some paint jobs are going to involve painting 1 bedroom, some are going to involve painting 2 bedrooms, 3 bedrooms, 4 bedrooms. Some jobs involve 1 paint coat, one coat of paint, right? Some involve 2 coats of paint. So every job is unique, so that's why job order costing makes sense. But let's say we're going to make units that are the same, and we're going to continue to make them in large quantities. Like let's say we're going to make this item. Let's say that we have a manufacturing facility and we're going to make this. Now, this is a product that will keep negative energy away from you. So think about it. This is the product that we're gonna make. All right. So gotta keep this handy at all times. All right. So what we're gonna do is we're gonna look at how. Remember we talked about materials. We talked about taking those materials and then converting them into work in process and then finished goods. So now we're going to quantify that. We're going to look at what percentage of the raw materials were actually converted. So what we're going to do is calculate the weighted average. And we're going to determine the number of equivalent units. Because in a given period, we may not convert everything. Remember we talked about that a couple of classes ago? We said that we have a certain amount of raw materials that we put into production. We have a certain amount of raw materials that we purchase. We started the period with a certain amount of raw materials. And then we use a certain amount of labor during that period to convert the raw materials into, ideally it's going to be finished goods, but sometimes, as we've seen already, we're going to have some work in process, which is the partially completed goods. And remember we said that we have to take that into account when we're trying to determine the cost of goods manufactured and the cost of goods sold. Because you can't sell a partially completed good. Right? What do? Sell a teddy bear without the arms? Or how do you, I don't know, could be interesting. Probably they expected to have the arms, the ears, the nose, the eyes. So we need to address that. The fact that we're not going to convert everything. We're not going to convert all the raw materials into finished goods. So we need to calculate the equivalent number of units. So let's look now at, in chapter 4, exercise number 2. All right. We're given some information here. This company called Clonex Labs. They use a process costing system, and this is the information that we have. We know the level of work in process that we have at the beginning of October is 30,000, and the work in process at the end of October, October 31st, is 15,000 units. We know that materials at the beginning of the month is 65%, and conversion is 30%. At the end of the month, materials is 80%, and conversion is 40%. The department started 175,000 units into production during the month and transferred 190,000 completed units to the next department. All right, so what we're going to do now is we're going to compute the equivalent units of production using the weighted average method. All right, so let's see what we started with here. All right, so it tells us 190,000 completed units were transferred. All right, so let's get down what we know. All right, the units transferred out is 190,000. Everybody sees where we got that, right? That's what they tell us. Now in this case, keep in mind, they give us the information. All we need to do is the calculation. All right, so what we're trying to figure out is the equivalent units. Units transferred out, they tell us, is 190,000. Now they give us some information about the work in process. So ending work in process as of October 31st is 15,000 units. And what else do they tell us?
That's times the 80%.
Right. They also tell us that conversion is 40%. Yeah, this is 80%. And this is just units. example, we're gonna look at dollars. So this is based on what they told us. They told us that at the end of the month, we had work in process, that's those partially completed goods, which is 15,000 units. %40 was converted. So that's 6,000 units. So total conversion was 196,000.
All right, first you did 15,000 units times 80%, right?
Yes.
All right, what's the next step?
Then what we need to do is look at what percentage, they tell us what percentage was converted,
Yeah.
which is 40%. That's how we get 6,000 units. So what we're trying to figure out is the equivalent
40%.
units.
What did you multiply the 40% with?
40% times the 15,000 units.
That's it.
Because remember, we're talking about the work in process. That's what we're trying to integrate here. Because they tell us that the units transferred out is 190,000. All right, so we don't need to do anything with that, right? We're good. They tell us 190,000, and we got this, so no worries, right? But we know that we're missing something. Just like we talked about over the last couple of weeks. We said, whoa, wait a minute. Yeah, I got you. We transferred out the 190,000 units, but wait a minute. What about the work in process? How do we take that into account? Because what we're trying to figure out is the equivalent units. So in this case, they tell us that conversion is 40%. What that means is that 40% of the work in process was converted into finished goods. Isn't that what that means? Remember, conversion, when we talk about conversion costs, are the costs that we incur to convert the raw materials into a product. But we said sometimes we complete it into a finished good and sometimes into a partially completed good. So that's what we're trying to get a handle on now. But they give us the information. They tell us that 40% of the work in process, those were the teddy bears without the arms. Now we attach the arms. How many of those is that? 6,000.
How can it be 80% in material still and 40% in conversion?
So
That will be 120%.
it doesn't need to sum to 100. We're talking about two different things. One of them has to do with materials, right? The raw materials. So let's take another example. You'll see how it fits together. Let's look at 4.3 now. All right, different company. All right, what is the information that we're given here? Our challenge is the same. What we're trying to do is figure out the equivalent units and the cost per equivalent unit. All right, so who could tell us? What's the information that we have?
Working process.
Yeah, Elena?
So we have working process for the 1st of May in terms of material, labor, and overhead. And then we have cost added during May. And then we have the equivalent units of production. And then you figure out the cost per equivalent unit.
Okay, so in this case, now here they tell us what the equivalent units of production are. Now, so it's a little bit different. Before we had to calculate the equivalent units, In this case, they're going to tell us what the equivalent units are. But what we need to do is figure out the cost per equivalent unit. So that we're going to, now we're breaking it down by materials, labor, and manufacturing overhead. And then we're going to figure out the total cost per equivalent unit. All right, so we start with the cost of work in process at the beginning of the period. We have material, labor, and overhead. They tell us what is the value of our work in process at the beginning of the period?
18,000.
18,000.
Thank you.
All right. So what does that mean? Who could tell us, what does this mean when we say, whoa, wait a minute, cost of the work in process, that's the partially completed goods. What do you mean, 18,000 material, 5,500 labor? What does that actually mean? What does that tell us? Go ahead.
That's the work qualifier period. It's like how much it costs to do that labor and the materials used. That's the overhead.
Right, so we have a certain items in our inventory that are partially completed. What we're trying to figure out is, well, what is that inventory worth? Well, we know. We know how much material we put into making those items. Even though they're not finished yet, we know how much material we put into making them. We know how much labor we put into it. And what we've been talking about, manufacturing overhead, we know how much manufacturing overhead is associated with that work in process. Everybody follow? So that's the cost. Remember we did a schedule of cost of goods manufactured. We looked at direct materials, direct labor, manufacturing overhead. But this is for work in process. So we have these partially completed goods. Then there's costs that are added. Now what happens when those costs are added? That means that either the costs that are added, which is either materials or labor overhead, those costs are either going to convert direct materials into finished goods or convert the partially completed goods, the partially completed items into finished goods. So we know that the costs added during the period are how much?
238,900 for materials.
So we used $238,900 worth of plastic, right? $238,900 worth of plastic, and
8,300 labor.
right. And then we have overhead is $401,500. So let's figure out what the total is there. So for material, the total cost for the period is $256,900. For labor is $85,800, and for overhead is $429,000. And they tell us the equivalent units of production. They tell us for materials is what, 35,000? What about for labor? 33,000. And for overhead is also 33,000. That's the equivalent units. All right, so the equivalent units, what we're trying to understand is the work in process, the partially completed goods that we completed during the period.
They will be finished goods, isn't it?
Right, that we convert them into a finished good.
Why we did not call them finished goods?
Because, well, we know what the finished goods are. We know during a given period how much labor and how much materials we use to convert the materials into finished goods. But we said, well, what about what we had already in inventory that was partially completed? How do we take that into account? That's what we call equivalent units. Because that's not something that we've already captured. That's the same issue that we've had over the last couple of weeks is how do we deal with the work in process? How do we deal with what is partially completed? And each time there's a little, slightly different challenge for us as accountants. This week the challenge is, well, what happens now if you take those partially completed goods and convert them into finished goods? We need to know, and the way that we take that into account is those are what we're going to look at as the equivalent units. Those were partially completed last period that now we've converted them into finished goods. So that's why we need to look at this. And what we're going to figure out is per unit. What is the per unit cost? So what we do is we divide these two. And we get the cost per equivalent unit. In this case is $734, $260, and $13. The total cost per equivalent unit is $22.94. So the total cost is this, 734 plus 260 plus 13 is 22.94.
Why do you need the total product cost when you
Go ahead.
I don't know, why do we need to calculate the total cost of
Why do we need to calculate the total? This is the total cost per equivalent unit. So if we don't calculate the cost per equivalent unit, then it's just lost in the total amount. Right? Which in the other example was 190,000. But then we found out that, well, the total number of equivalent units in that case was 196,000 because we had converted some partially completed goods. So remember, we keep going back to, well, what is our actual cost? That's what we're trying to get to now, which we didn't know that before. Now we know what is the total cost per equivalent unit. Before we just had the total. This is what we started with. Just the total. But now, in this equation, in this example, in this scenario, they told us what the number of equivalent units were. In the first example, we had to calculate it. Well, now that we know what the equivalent units are, the total number of equivalent units, then we could calculate the total cost per equivalent unit. That's what we want to find out. Because remember, there's a difference between, like in the first example, remember there's some of those partially completed goods that became finished product.
Yes. You multiply.
So, yeah, go ahead.
Yes, I remember. You multiply 15,000 by 80%. This is just example, and it is,
So in this case, they tell us the number of equivalent units. So now that we know the total number of equivalent, now we know the number of equivalent units, and we know what the costs are. Well, how much cost? What was the cost of the partially completed goods, and then how much cost we added during the period? How much did we put into labor? Right. This is what we paid the wages for our people in the factory. This is the cost of the plastic. Now we want to know what is the cost per unit. That's what we calculated here for the total cost per equivalent unit, which we didn't know before. That's ultimately what we're trying to find out, right? How much does it cost us to make a unit? Well, before that, we didn't know. When we started out here, we didn't know. We knew that we had some costs in work in process. We knew that we added these costs, but then how much does it cost to make one teddy bear? We really didn't know until now. Now we know per equivalent unit how much it costs. Because what we're trying to pull apart is the fact that during the period, we're going to take a certain amount of material and we're going to convert that, we're going to try to convert that into finished goods. But in any given period, some of it will be finished, and then some will be left over that the period ended and that's it. That's work in process. Those are the teddy bears without the arms. But then, see, this is why we've got to do this. Then you say, well, what about the teddy bears that we had that were left over from last month that didn't have any arms? How did we take that into account? What happened to them? Did we finish those? Well, we need to compute that. And remember we said, well, what was for example, the work in process that we had at the beginning of the period, and what was the work in process that we had at the end of the period? And if we had, let's say, 30,000 at the beginning of the period and 10,000 at the end of the period, then what does that mean? Who could tell us? If we had let's say we had 30,000 teddy bears at the beginning of the period, partially completed teddy bears at the beginning of the period. Then at the end of the period, instead of 30,000, we have 10,000. So, Irina, tell us. So that means that we converted them into finished goods. Assuming I didn't take one for all my students and bring it to campus. We're going to assume that whatever was in inventory, nothing was taken, and we converted that. That's what we need to address. That's what we're trying to get a handle on. Because remember, all we know is the total cost. We know the total cost, but we know that we didn't convert everything. There's a certain amount of partially completed goods. And just like when we did the schedule of cost of goods manufactured, we have to address that. And so that's what we're trying to understand now is, what is the equivalent number of units, which means taking into account the partially completed goods, and then once we know that, in this case they tell us, we don't need to compute that, what is the cost per equivalent unit? So let's take another example. Let's look this one combines question 1 and 2 together. This is exercise 8. All right, this one is pure form. Pure form manufactures a product that passes through 2 departments. And they give us some data for the recent month for the first department. They tell us the work in process, 5,000 units. They tell us the units started in process, the units transferred out, the work in process ending, and the costs that are added during the month. That means for the 52,800, what does that mean? That's cost added during the month. But what does that mean? 52,800 for materials.
Units.
Go ahead, tell us, Melissa.
Raw materials are purchased.
Close. In this case, we need to know what is the raw materials purchased, but in this case, they're telling us that, what? It's the raw materials that are used. The cost of the plastic that was used. That's why we're going to add this. And labor, they say the cost added during the month is 21,500. That means that's the amount of labor that we had to pay to convert the raw materials to either partially completed good or a finished good. All right, so how are we going to tackle this? Now keep in mind, this is a combination of the first 2 examples, right? So very similar. Now we're just going to take it to the next step. All right, they tell us the units that are transferred out. In this case, they tell us it's 42,000 units. Right, not dollars, units. So we're looking at units again. Remember, what we're trying to do here is calculate the weighted average. All right, they tell us the work in process at the end of the period. $8,000, right? All right, now look below the chart, they give us some additional information. What do they tell us? All right, read that carefully because we're gonna need that information.
Standard working process inventory was 75% complete with respect to materials and 50% complete with respect to labor and overhead.
80 and
Who was that?
6. My book says 80 and 6.
Right, so it says the beginning work in process inventory,
The beginning work.
The beginning.
right? The beginning partially completed goods, WIP. The beginning partially completed inventory was 80% complete with respect to materials. See, we don't need to guess. They're telling us the information. And 60% complete with respect to labor and overhead. The ending work in process inventory was 75% complete with respect to material, and 50% complete with respect to labor and overhead. All right. %75 complete, right? They tell us it's 8,000 units, right? With regard to material, with regard to labor and overhead. 75% with, okay, right, is 6,000. And then with regard to labor and overhead is what? So for materials, that gives us 48,000 units. We're going to look at dollars in a second. 46,000 units, equivalent units for labor, and 46,000 equivalent units for manufacturing overhead. Why is
Isn't
it
it
42?
4,800? Why 50%?
That's what it tells us. It tells us that in the second line there, it says,
Oh,
with
okay.
respect to materials, 50% complete with respect to labor and overhead. And they tell us that WIP at the end of the period is 8,000. So now that we got the units, now we're going to use the cost information that we have to get the cost per equivalent unit. So they tell us, right, so all of this is units. Now we're going to look at dollars. All right, how much is materials? Work in process at the beginning of the period, they tell us that materials is 4,320. Labor
1,040.
and overhead?
1,790.
Okay, good. Now, somebody explain to me what that means. What does this mean when we say at the beginning of the period we have some WIP?
Because it's being carried over from the previous period.
Yes, and this is carried over from the previous period. And what does this mean? What does this number mean, 4320?
That's how much money of materials is being used.
Right, that's how much materials we used last period to produce the item. And this is how much labor, and this is how much overhead. All right. Now we're going to look at the cost added. What is it for materials? And for labor? And what about for overhead? Okay, so who could tell me what does this mean? What is this 52,800? 52,800. What is that? What does that mean? Irina, go ahead, tell us.
Raw material we use this period.
Right, that's the raw materials that we use this period. And that's the plastic, right? How much plastic we used. And what does this tell us? 21,500. The cost of the labor to convert the materials. All right, so let's look at the total cost. This is 57,000. Now we have the equivalent units of production, and we calculated that. We said the equivalent units of production is 48,000 for materials, 46,000 for labor, and 46,000 for manufacturing overhead. Cost per equivalent unit here is $1.19. This is 49 cents. How does this help us? What is it? What are we going to do with this information? What are we going to do with this $1.19, with the 74 cents? Why are we trying to figure that out? What do you think? Go ahead.
And determine how much to sell it for.
How much to?
Sell it for, or the cost of the product.
Absolutely. That's good. We need to know, in order to set a price, we need to know what our costs are and what else as managers in trying to run this business.
If it's profitable.
Absolutely. We want to know whether or not we're going to be profitable, and
They're going to decide to produce it or buy it.
if we have to know, exactly, we have to know whether or not to make or buy.
Or sell. How much it will cost.
Right. How much we're going to sell it for, and whether or not we're going to make it ourselves or we're going to buy it from somebody else. You need to, in order to do that, we need to understand the cost. And then also, we're going to do some sensitivity analysis. Now that we know this, then we could say, well, what about if the equivalent units of production instead of 48,000 was 58,000? Or 68,000? Or 78,000? Remember we said that as in managerial accounting, we're always trying to use the information to make decisions about the future. Like you're saying, right? Are we gonna...
Yes, we need to make decision about the company, what we're doing right now, or what we're going to do tomorrow.
Right, absolutely. So it's not, we're not gonna focus on past performance. Of course, that's important. That's what we're gonna do. That's what financial accountants do. That's the focus of financial accounting. And that's certainly very important. But in order for us to get to the end of the year, we have to make some decisions. How many units are we going to produce? And if we produce those units, importantly, what will be the cost? So once we know, once we've teased out, right, that's what we're trying to do, is we're trying to break it apart so that we understand how much of the cost, how much did it actually cost us? At the end of the period, how much did it actually cost us? Not just to convert the raw materials, but also to convert the WIP. That's where it starts to get a little tricky, right? That's what we need to figure out. And by the way, when we say raw materials, we use the term raw materials and also direct materials interchangeably. When we say raw materials in this situation, we don't really mean, it doesn't need to be coal, for example, or steel, or cotton. It just means the materials that we use to make the product. So very often we use the term direct materials, because usually when people think of raw materials, they think specifically of, right, some specific type of raw material that you might use in production. So for example, to make a car, of course you're gonna, I was gonna say you need to use steel, but I think it's basically in make cars that are plastic now, right? So you're gonna need plastic, but you're gonna need other materials as well. All of those materials are what we mean when we say direct materials. All right, how are we doing on time? All right, we're doing good. You guys need to take a break? No? Okay. All right, we'll keep going and see if we can get out of here before midnight. All right, for homework, you guys do You guys do 411, and I'm going to show you how to do 413. All right, so you guys do exercise 411.
This one?
Yeah, just that one.
How many questions will they have on the new job?
The midterm is going to be approximately 30 questions with 3 problems.
The multiple choice.
Yeah, there's going to be some multiple guess problems, and also some, there's definitely going to be some computational questions as well. So what is one of the problems that is going to be on the exam that you're going to have to do? Who could tell me? Yep. You're going to have to do that on the exam. So go through, so we went through a few of them already. Go through some more problems like that. So we did, which one we did? The Swift Company, we did Superior. There's another one that's a good one that's called Mason Company. Take a look at that one. All right, let's look at problem 13. All right, problem 13 takes us a little bit further. What problem 13 does is shows us how to do the course reconciliation. And what is that? Basically what that is it's a combination. Ultimately what we're going to do is we're going to look at the cost of the ending work in process. So the cost of the ending work in process, and then the cost of the units completed and transferred out. So that's what the cost reconciliation is going to allow us to calculate. So the ending work in process and the cost of the units completed and transferred out. All right, so who's going to read this for us? Sunspot Beverages. Sunspot Beverages of Fiji makes blended tropical fruit drinks. Sounds good, right? In 2 stages. First, the fruit juices are extracted from fresh fruits. So there's an extraction process, and then they're blended. So the fruit juices are blended together. The blended juices are then bottled and packed for shipping in the bottling department. The following information pertains to the operations of the blending department for June. So what we're going to do is we're going to determine the equivalent units, compute the cost per equivalent unit. We're going to determine the total cost of ending work in process inventory and the total cost of units transferred to the bottling department. All right. So this company makes this fruit juice. It's like Snapple. So let's see how they do this. So you see why there could be some work in process here. What would be the work in process in this situation, based on what they tell us? In this company, they make this fruit juice. What's the work in process? How could they?
Juice that's already been extracted.
But, right, they didn't blend yet. Now remember we said that it's not a bad thing to have work in process. In fact, very often, work in process is planned. You plan to produce some work in process. You plan to extract, right, depending on how your facility is set up. You might actually plan to spend, let's say, a week just extracting juice. And then the next week you might spend blending the juice. So it's very common to have work in process. Now the question is, how much work in process do you have? How much finished goods do you have? That's something that we need to manage carefully, because you don't want to have too much inventory. You want to have enough, but you don't want to have too much. Why? Why do we care about how much inventory we have? Why does that make a difference? Who cares? So we'll have, why does it matter to us if we have 1,000 teddy bears or we have 1,000,000 teddy bears in the warehouse? Why not? The more the better, right? Then we have an early start on next year. What's the problem?
It costs money. You don't have money
It costs money. What does that mean?
It means you cannot storage too much inventory. You need money in the process. If
So-
the money too much inventory, what we gonna do now? It's a lot of money.
So our direct materials, our labor, our overhead, those are all costs. Remember I said, what does this number mean? 52,800. That's the cost of materials that we used. Well, if we're using all these materials and all this labor, and then at the end, the teddy bears are sitting there in the factory, that's a problem. Now, of course, again, you have to build some inventory, but you don't want to have an excessive amount of inventory. You want to have enough to meet demand, and very often, depending on the industry, usually it's common to have 3 months worth of inventory. 3 months worth of inventory means that you have enough to meet the demand from Target or Pathmark or whoever the company is for the next 3 months. Now, why would you do that? Assuming that you already know what their demand is, why are you building inventory?
Customers place order, you need to be ready to give them material or something like, beers or something.
Right, whatever it is, you have to have, the product has got to be ready to ship. Now, when we get the order from all our customers and they tell us, well, now total, let's say we need 942,000 units. Well, we can't make that in a weekend. That means if you can't make that in a weekend, that means you had to make it the month before, or the month before that, or the month before that, and then store the inventory so that when you do get the order, you're going to have the product on hand to be able to ship.
You need to think, you need to make decisions before.
Right, absolutely.
Make plan.
That's right. You have to have a production schedule that's going to allow you to meet demand, because you have certain capacity limitations. That means there's only so many units that you can make in a day. And you need to know that. So once you have your forecast and you know that in a given year that you need to produce, let's say, 2,475,000 units, now you're going to figure out, well, how long is it going to take you to make them? And when are you going to make them? Now, in some cases, there's a lot of businesses that are very seasonal. And so that means that they're going to see, out of that 2,700,000-something, maybe 2.5 million of those units, they're going to sell in the fourth quarter of the year. And if they're going to sell that in the fourth quarter of the year, that means that in January, February, March, April, May, June, the first 3 quarters of the year, they're going to have to be producing the product. Because you're not going to be able to make all that product in the last couple of months of the year for most products. You have a certain limitation. Even if you go to 3 shifts, there's only so many units that you could make in a given day, in a given week, in a given month. So you have your forecast. You have to, in many cases, hold inventory. And in some cases, it's not finished good inventory, it's partially completed. And one of the reasons why you might wait is why? Is because once you convert it, you're putting more money into the product. You're putting more labor. You're incurring more manufacturing overhead. That's why, for example, some companies, what they do is they produce the product and then they wait to package it. Why? Because especially corrugated cardboard that's used to package most durable products is very expensive. Very often, it costs more for the packaging than it does for the product. So they say, you know what, let's just wait before we start spending more money on cardboard and labor to package it. Packaging they can do pretty quickly. Making the product is usually more time consuming. So let's not start paying the people overtime, doing double shifts and so on, because we're tying up cash. So let's look at this Snapple wannabe company. The first thing we're going to look at is equivalent units. So what do they tell us? What's transferred to the next department? Materials is 160,000 units. Conversion, they tell us, is also 160,000 units. Then they tell us the ending WIP. They tell us materials and conversion. How many units? We don't need to calculate. They tell us how many units for ending work in process. 40,000, right? 40,000 units. Conversion is also 40,000 units. Materials, they tell us, is 100%, which is 40,000 units. And conversion is 25%. Which gives us 10,000 units. So the equivalent units of production is, how much is it for materials? 200,000 units. We're going to talk about dollars. But right now we're looking at units, and 170,000 converted units. All right, let's look at the cost. So we have the equivalent units of production. Now we're going to look at the cost. All right, they tell us the cost of beginning work in process. All right, so for materials, it's 25,000, right? 200. Conversion is 24,800. That's the cost of the working process at the beginning of the period. Cost added. They tell us materials is 334,000, and conversion is 38,700. What do we mean when we say conversion cost? What's the conversion cost? You know?
You just asked this that, didn't you? Does the cost convert the raw materials to the product?
Right. I'm going to keep asking. I'm going to keep asking until everybody knows. And what does that actually mean? Because remember at the beginning, the first week, we talked about the different terminologies, but I think some of you are still a little bit fuzzy. You're not fuzzy anymore, but I think there's still some fuzziness. What is this? We talked about, remember the first I wrote this little diagram over here? and we talked about product cost, period cost, direct materials, direct labor, manufacturing overhead. And we said product cost and manufacturing cost are the same. Period cost and SG&A, selling general administrative, or non-manufacturing costs are the same. And then we said conversion cost. We said conversion cost is what? I heard part of it, I heard the first part. Right. So that's why we list it this way, because this is the direct, I don't think this one last. This is the direct materials, and this is direct labor plus overhead, manufacturing overhead. So that's why here we call that the conversion cost. What is the conversion cost? We know that the conversion costs are, like Ms. Rahim is saying, right? That it's the cost to convert the direct materials into product. And what is that cost? Well, in order to convert the direct materials, you gotta use labor, and you can also incur some manufacturing overhead, which we said is indirect labor and indirect materials. So that's what we're looking at here. So same thing, like when we started off, we talked about, when we did the schedule, direct materials, direct labor, manufacturing overhead. We're still focusing on that, but we're going to combine direct labor and manufacturing overhead and focus on conversion. If you want, you could show it separately, but really what we're focusing on is what does it cost to convert the materials.
Professor, what is the difference between units per product and equivalent units? What is the difference between them?
This is the equivalent units of production.
Yes. What is the difference between units and equivalent units?
These are, here I wrote units because we didn't talk about dollars yet. So all of this is units. All of this is in units. But these are the equivalent units.
Why do you need to put the equivalent units?
That's what we just talked about. We can talk about it after class. I'll explain to you again. Because remember we said that there's some work in process that we need to address. Right, the partially completed goods. That we can't lose track of those. All right, so this is the cost that we're adding. All right. One more time. You ready? What does this number mean? I know it's a nervous laugh. Wait till you see it on the exam. Right? Because what I want you to know is I want you to be able to intuitively understand what is the application. Like, what is this like really about? Like, I need to know that you know that this is. Go ahead, tell us.
Raw materials.
And what does that mean?
That means the products that we use, is it?
It's the cost of the plastic that we used that period.
Of raw materials.
So we say, right, so this is the raw materials, direct materials. This is how much raw materials we use in this period. And this is the partially completed goods. So how much is this? What is the total? And? Now we already calculated the equivalent units, which is 200,000 and 170,000. So the cost per equivalent unit is, right? Who's talking? Siobhan, okay, $1.55. All right. Good. Now we're going to take it the next step. You ready? We could do this. All right. So now we know the cost per equivalent unit. We know what the equivalent units are. So let's see if we could determine what is the cost of the ending inventory. So what is the cost of these 40,000 units and these 10,000 units? Now that we know the cost per equivalent unit, now we could figure that out.
72,000.
Yes, 72,000. All right, so can I erase this? Everybody's got this? Silence means agreement. There it goes. All right, so now we're going to apply these costs to the units. All right. This is step 3. Ending with. Remember in step 1, we said this is 40,000. We calculated that at 40,000 units. This is 10,000 units. Now we know that the cost per equivalent unit is $1.80 for materials, and Siobhan told us $1.55 for conversion. Now we know the cost of the work in process at the end of the period. Which is simply, in this case, $1.80 times 40,000 units gives us $72,000. And 10,000 multiplied by $1.55 gives us 15,500. All right, we're getting there. All right, this is work in process. Now we're going to talk about the units completed and transferred out. So that we're told how much that is, right? But we want to find out the value. How many units? Right. 160,000 materials, 160,000 units conversion. We know that the cost per equivalent unit is still $1.80 and $1.55. So the cost of the units completed and transferred out is how much? Yes, 288,000. Yes, 248,000. These two combined is 536,000. And these two combined are 87,500. So now we've calculated the cost of the ending width and the cost of the finished goods. Right, isn't that what this is, basically? Units completed and transferred out. That means those are the finished good items. So now we know what was work in process, partially completed, and the value of what was completed. Remember, we're trying to figure out the cost. That's what we're getting to. Right? That's why we're doing this. Now we're going to do the cost reconciliation. And then we can go. And that's why we calculated the cost per equivalent unit. Once we know that, then we can calculate the ending width and the value of the finished goods. All right, so look at the part 2, cost of beginning work in process, right? When we calculated the cost per equivalent unit. Now what we're going to do is we're going to combine those two amounts. So when we calculated cost per equivalent unit, we had the cost of beginning work in process. Materials were $25,200. Conversion was $24,800. So how much is that? So how much is the cost of the work in process at the beginning of the period? Right, 50,000. That's materials and conversion costs. And then we have the costs that are added to production. Which is how much?
506.
Close.
573,000.
Yes. Go ahead, tell them how you got that, Siobhan.
The cost added for materials was $334,800, plus the cost added for the conversion was $238,700.
Everybody got that? Tell them again, Siobhan.
The cost added for materials was $334,800, and the cost of conversion was $238,700. We add those together,
Right. That gives us the $573,500. So the total cost to be accounted for is 623,500. That's the cost that we need to account for. Question?
Yeah, so we get 50,000.
50,000 is in part 2 when we did the equivalent units. It's the 25,200 for materials. That's the cost of the beginning WIP. And 24,800 is the cost of conversion. Now when we're doing this reconciliation, you see it says the cost to be accounted for. So now let's see if we could account for these costs. We have the cost of the beginning WIP. We have the cost that we added to production to convert the raw materials. So now let's see if we could account for those. So if we did everything right, it should be this amount, 623,500. So let's see. The beginning WIP was 50,000. But the cost of WIP at the end of the period was what?
87,500.
Right. You see how we got that? Here we calculate the cost of WIP at the end of the period. 72,000 materials, 15,500 conversion, which is 87,500. So what do you think? Is this going to add up? Because look, here we said 50,000. Now we're already at 87,500. We got to get to this number. So let's see if we can get there. So then we have to look at the cost of the units completed and transferred out. Which is what? Which is this, right? Well, these numbers are different. Here we have 50,000, here we have 87,500. Here we have 573,500, and here we have 536. So we gotta see. Let's hope. Let's see what happens. All right, here we go.
Is this from
The same?
Professor Bassell, is this from China?
Turkey.
Turkey. Wow.
Turkey. This is
Because I remember you said you was in China for several years.
yes, right, I've been in China quite a few times. But this is probably made in China, but this is actually part of Turkish culture. The evil eye, which is supposed to,
Stone.
yeah, it's glass, supposed to repel negative energy.
It doesn't work, believe me.
It doesn't?
No, it doesn't work for me.
No, it works for me.
No,
I'm feeling lucky today.
don't forget.
All right. Questions? So you just gotta follow. You just gotta follow the format. But importantly, what I've been trying to go over with you again and again is how you get the numbers, what those numbers mean. But I think you're gonna be able to do it. Yes, you can, Melissa. Yes, you can. You see? The evil eye is working. Positive energy, positive thinking.